All right, ladies and gentlemen, for today's presentation, we're going to start discussing measurement. When we were talking about our scientific process and the method that scientists use to understand the world, we made a big deal about how there's multiple types of data. How scientists like to collect qualitative data, which is based upon descriptions and observations, and they like to collect quantitative data, which is based on numbers. And they prefer quantitative data because you can't really argue about what a number is. So instead, what we can do is argue about what it means. However, what we need to discuss, particularly in sciences like chemistry, is how do you collect number data? How do you collect quantitative data? And to do that requires measurement. So what we need to do is talk about how much there is into a chemical reaction, how much there is out of a chemical reaction, how far a chemical reaction can go, how long it will last. There's numerous things that we can measure. And so that's what we want to talk about in this presentation, is get into some of the details about measurement. So first thing we want to do is sort of discuss the broad categories of measurement. In our next presentation, we're actually going to talk a little bit about specific values, specific units we use to label them. But what we want to discuss here is sort of the broad category of what they fit in. So first off, you have length. All right, now length is a measurement that's all about distance, or how far something is, how far something goes. We also have to talk about mass. Mass is actually a specific measurement about how much of something there is. Now keep in mind, mass and weight are not the same thing. They are similar, but they are not the same. Okay, mass is a measure of how much of something there is. We also have volume. Volume is a measurement of how much space something takes up. Time should be an idea that's pretty easy for you to wrap your head around. It basically is just how long something lasts or how long something takes. And then we also have temperature. And temperature, it's something that we all sort of understand, but probably don't really think about what it means. And so for us, temperature is how much heat something has. Now, these are the basic measurements. You actually can combine measurements. For instance, I'm sure you're all familiar with how you calculate area. You calculate area by combining multiple length measures. And in fact, that's one of the two ways you can calculate volume, is by combining multiple length measures. When it comes to things, other measurements that are more detailed or more specific, we can combine multiple of these measurements, such as density, which is mass and volume that we work with together. And so these aren't the only measurements, but they're sort of the baseline measurements. Okay? So when we are collecting these measurements, what we need to do is know how to use the tools appropriately. So what you see on this image in front of you is a ruler. Now we're all familiar with a ruler. We all know how to take measurements with a ruler. But what you probably don't know is how do you take a precise measurement with a ruler. And so rulers are what we call non-digital. You can see that right here. Non-digital measurement tools. And so whenever you're using a non-digital measurement tool, you're going to have to make an estimate. So what you do is you measure to the smallest unit that's on the ruler. Now you can see on this ruler you have centimeter lines, which are the lines that have the numbers, and millimeter lines, which are the small lines in between the numbers. So you're going to measure to the smallest unit and then estimate the next number, which frequently will be a decimal. All right? So you take a look at this, and you see this blue line I have drawn here. And you see how the 14 here, there's a line that's right along that 14. So what I would do if I was measuring with this ruler and it went from 0 to 14 is I would say that it measures 14 centimeters. But since I see it exactly on that line, I would say that it's 14.0 centimeters. Because what I'm saying with that 0 is that my estimate is that the line is exactly at 14, not a little bit above it. And so that 0 is my estimate. And when you're using a non-digital tool, you will always estimate one place. Let's take a look at another example. Just sort of make sure we get this right in our head. So this image that we're looking at now is a thermometer. And you can see on the left you have Celsius values, and on the right you have Fahrenheit values. And where I've drawn that red line is actually where the thermometer measure, the alcohol that's inside of it, has gone up to. So if I was looking at this, what I would see is that this is 60, this is 80, which means this line in the middle is 70. So that means that each one of these lines is 2 degrees. So 62, 64, 66, 68, 70. And so what I'm seeing is 72, 74, 76, 78. So it looks like this is at 74. And since I see it as exactly 74, this is my measurement using the non-digital tool, and 74.0 with the 0.0 is my estimate. So again, I'm saying that this is exactly 74.0 degrees Fahrenheit. I am estimating that it is exactly on the 74 line. Whereas on the other side, if I was going to repeat this process, I have 20 and I have 30. So 22, 24, 26, 28, 30. So again, each one of these lines is 2 degrees. So what I see is I have 22 and 24, but my red line is just below that 24 line. So what I would say is that this is 23, say 0.9. Because I know it's at least 23 because it's above the 22 line. So this is my measurement. And since it doesn't quite make the 24 line, what I'm saying is that I think it's almost at the 24 line, and that makes this my estimate. So whenever you are using a non-digital tool, so a tool that doesn't display numbers for you, that doesn't calculate things for you, you have to measure to the smallest point you can and then estimate one more. And we will practice this. So here's an example of a digital tool. So this balance here is a digital tool. And you will notice that it says 50.08. So whenever you have a digital tool, and all digital tools are designed this way so that we can always read them correctly. These numbers are measured, but the last number is always estimated. So basically all the jewelry on that balance definitely weighs 50.0. And it definitely weighs slightly more than 50.0. But the digital balance is estimating for me that it's 50.08. And that's really important because I don't need to do anything. When I was using the ruler right here, I was saying 14 is what I saw, and then I have to say 0.0 because I'm estimating. But because the digital tool is already giving me that last number, it's already doing the estimate for me. All I need to do is be aware that that last number is not an exact measurement, but that last number is a measurement. Now, taking measurements is a huge part of doing science. But taking measurements properly is just as important. And so that gets into something that we call accuracy and precision. Accuracy is how close your measurement is to correct. And precision is how close each measurement is to each other. So let's talk a little bit about some of the details here. So accuracy, you'd usually have an expected. measurement. And so when you're taking measurements and you're trying to decide if they are accurate, you are comparing them to your expected. The expected is something that you either look up in a reference book, something that you're told ahead of time, or you take a measurement once and then you repeat the experiment and see how it compares to your first time. Precision has to do with the fact that whenever scientists do experiments, they always take multiple measurements. I don't measure something just once and assume that that's correct. Frequently, I will repeat an experiment or repeat a measurement 4, 5, 6, 7 times, 10 times, 20 times, because that way I can be sure that the results I get or the measurements I took are correct. And that's what precision is. It's when you take those multiple measurements, you know that those measurements are very close to each other. And so you can trust that the measurements were the right measurement. Frequently when explaining this, we use either a bow and arrow or a dartboard. So you can see on the image here, there's a dartboard. So all the way to the left, right here, none of those darts are in the bullseye, and none of those darts are near each other. So because none of them are in the bullseye, this is not accurate. Because none of them are in close proximity to each other, they are not precise. You see this one right here, the second bullseye, the second dartboard. That dartboard is precise because look at how close the darts are to each other. But it's not accurate. Because look, nobody's in the bullseye. You look at the next one, not precise, not accurate. None of the darts are near each other. None of them are in the bullseye. But if you look at this last one here, all of them are in the bullseye and all of them are close to each other. That last one is precise because they're all close to each other, and it's accurate because they're all in the bullseye. That is what scientists strive for. All right, that's all we're going to do for this presentation. And next time we're going to talk about some of the units we use for measurement.